Hello and welcome back to the final video in this series looking at some of the really tricky calculations that you need to do for the quantitative chemistry topic at GCSE. So this last video is triple only content, so if you're doing combined science you don't need to worry about this calculation. So this is looking at how we can use gas volumes and our understanding of moles in order to solve some problems. So we've got a reaction here of methane, CH4, reacting with oxygen to produce carbon dioxide and water. And I've put in the state symbols there for each of our chemicals because they're going to be really important in this calculation. So we've got 32 centimetres cubed of methane, reacts with 70 centimetres cubed, that's an excess of oxygen. So we've got more oxygen than we need for this reaction. Assuming the reaction is done at room temperature and pressure, calculate the total volume of gas at the end of this reaction. So with this particular idea, we need to know a key fact about the volume of gases. Okay, so I'm just going to write this down below to help us. 1 mole of any gas, so it doesn't matter the what the gas is, it doesn't matter what the relative formula mass of the gas is, 1 mole of any gas takes up the same volume at room temperature and pressure. I'm just going to abbreviate that to RTP. Now, the actual volume that it takes up at room temperature and pressure is 24 decimeters cubed. So in some calculations, you will need to use that constant in order to work out the volume of gases or the number of moles of gases. However, for this particular equation, this particular question, we won't actually need to use this number because we can just use the molar ratio in our question, because our question is involving pretty much all gases. But that's our key fact that we need to use to answer this question. 1 mole of any gas takes up the same volume at room temperature and pressure. So let's bug the question to find out what we need to do. 32 centimetres cubed of methane reacts with 70 centimetres cubed, which is an excess of oxygen. Assuming the reaction done is at room temperature and pressure, so that means the assumption that we've made down here, the statement we've made down here is correct. Calculate, that's our command word, the total volume of gas at the end of the reaction. Okay, so with this particular question, the first thing that we're going to start off with is by working out how many moles of gases we have produced. Okay, so if we look at the equation at the top, methane is a gas, oxygen is a gas, carbon dioxide is a gas, but water is a liquid because we're assuming it's done at room temperature. Okay, so that means the only gas that we are producing is carbon dioxide. So the first thing I want to calculate is the moles of the volume of carbon dioxide. So volume of CO2 will equal, well, because 1 mole of any gas takes up the same volume, if we've got 32 centimetres cubed of methane and that's our limiting reactant, then that will mean that we will also produce 32 centimetres cubed of carbon dioxide. How do we know that? Well, one thing, they're both gases. The second thing, let's look at the ratio. It's a 1-to-1 ratio. Okay, so volume of CO2 produced equals the volume of methane, okay, because the methane was the limiting reactant, okay. So the volume of carbon dioxide, because it's a 1:1 ratio, we will have made 32 centimetres cubed of carbon dioxide, okay. Now you might think, that's the answer then. Not quite, because the oxygen that we reacted it with was in excess. So that means some oxygen will be left over, okay? So we need to work out how much oxygen our methane will have reacted with, okay? So just move my camera down slightly. So the ratio of methane to oxygen, if we look at our symbol equation, is a 1:2 ratio. So I'm just going to put underneath 1:2 ratio. So that means that 32 centimetres cubed of methane will have reacted with, and because 1 mole of any gas takes up the same volume, all we need to do is double that volume of methane. 32 centimetres cubed of methane will have reacted with 64 centimetres cubed of oxygen. Okay, so how much oxygen have we got left over? So oxygen left over equals, well, we had started with a total of 70, so we do 70 centimetres cubed, take away 64 centimetres cubed, because that's how much reacted. So that means we've got 6 centimetres cubed left over. And so your final step, the total volume will be the volume of carbon dioxide, which is 32, plus the volume left over of oxygen, which is 6. And so that gives us a final total volume of 38 centimetres cubed. Okay, so let's have a look at where we would get the 4 marks for this question. So you would get 1 mark for identifying it was a 1:1 ratio of carbon dioxide and methane, and therefore we would produce 32 centimetres cubed of carbon dioxide. You would get 1 mark for working out that 64 centimetres cubed of oxygen reacted. You would get 1 mark for working out the leftover oxygen was 6 centimetres cubed. And your 4th mark is to add together the volume of carbon dioxide and the leftover volume of oxygen to give you the 38 centimetres cubed as your total volume. So I hope you found this model answer useful. You will need to just have a little look at some calculations of how we use the 24 dm cubed in there as well. But if you're just dealing with gas volumes and the molar ratio, you can just use the ratio of those volumes in order to answer the question. So I hope you found this series of videos useful. Keep working hard, and I'm sure you'll all do well in your GCSEs exams. Well done everyone, I shall see you next time.